Hello guys, welcome back to my channel DP Design, and in this video I am going to show you the simulation or teach you the simulation of the 3-point beam bending analysis using Abaqus and SolidWorks. So let's get started. So as you can see, there is a demo done over here where one fixture is coming like this in the downward direction and two of them are fixed. So whatever the bending of beam, whatever the stress level or displacement level, you can check, and we will go through every details how to do this kind of simulation. So you can do more, you can explore more simulations using this constraint. So let's get started. So here I'm using SolidWorks for modeling first, because it will be easy to separate the bodies. Okay, so let me create one beam. Let's say I'm creating a beam. I'm giving dimension around 200. Okay, and my thickness will be my height will be 20 and my thickness will be around 10. Okay, 10. Yeah. So here is my beam. Now I will sketch 3 fixtures now. Okay. So let me create one fixture over here from the middle, and two of them are, this is not vertical. Okay, I make it vertical, and yes, and I will keep the mirror about this, mirror about this, and okay, yeah. So I will give the dimension to the circles as 20 mm. This will be also 20 mm. We also 20 mm. Okay, this is mirror, so I don't need to constrain this one. So as you can see, so I should get it done as a tangent over here. Okay, and this also. Okay, now as you can see, my 3 points are created, and I will extrude this. I will keep the merge result off because it will combine my bodies, so it will create as a one body. As you can see, if I keep it merge result on, okay, so it will be difficult for me to export the bodies, but let's keep it a merge result off. Okay, it is off already because there is no interaction between two bodies. No problem. Okay, my model has been created. Now I will export it as a step file to perform the simulation of beam. Now I will close my Abaqus for now. Okay, I don't want to save, and now I will open the Abaqus. Okay. Now as you can see my screen, I will select the standard or explicit model. Now I will import my part, which is at a desktop, I think. Yes, on desktop, and trash. Okay, 3 point. No, I saved here only beam step file. Okay, so here you will get the options like create individual parts or combine into single part. We want to create individual parts. There are total 4 parts are there. So as you can see, there are 4 parts imported over here: beam 1, beam 2, beam 3, and beam 4. So first we have to create the material and apply the section over this part. So what you can do, you can create the material. Let's say I am giving the steel properties to this part, and I will give the mechanical and elastic, okay, which is 200 GPa. I am putting the values in MPa, and my Poisson ratio will be 0.29. I don't need to define the density because it's not a dynamic analysis or inertia related, so I will keep it as a for now. So now I will create the section. Let's say this section is my steel, homogeneous. Okay, I will select the material as a steel as I have created, and you can select the okay. Now your section has been created. What you need to do, you have to apply this section to this part. So whatever material applied in this section, that will be directly applied to this part, whatever you can see. So I will go to the section assignment, and if you click the section arrow, it will ask you to select this set, which is this one, and I will okay, done. Okay, whatever section you have created, it will come over this region. Okay, so as you can see, my product is green, mean my material has been already applied. Okay, I will do the same for every part. This also. Even if you make this product as a discrete rigid, there is no issue. You can do the simulation, because we are going to make this as a rigid body only in the future. So in the assembly, whatever part we want, whatever instances we want, we will apply those instances, and I will create this. Let's say my 4 parts should create, and I will select the dependent, which is a mesh on part, where you can individual do the mesh, and in the independent you have to combine, you can give the combined meshing. Okay, so I will always choose the dependent because it is easy for me, and if I want to change on one part, you can change the meshing as well. So I will keep it as a dependent. Okay, now what should I have to create? I will go to the tools and I will create the reference point, which can be called as a RP in Abaqus. So wherever you create, there is no issue wherever you can create the RP. Let's say I'm going to create here, here, and here. So let's say my rigid body will be 3, first, second, and third. This will be my rigid body. Okay. Now what kind of simulation I want to do? I want to do dynamic simulation, static simulation, or what? So for now I have to create the static simulation. I will select the static general analysis, and step 1 is my static condition. I will write down. Okay. Procedure type general, obviously, yes. Okay. Now I will select the non-linear geometry on, because it can be a large displacement. Okay, so you can click it on. For the maximum iteration, you can apply any numbers, any huge number, but it will complete in a very short. So initial increment size, I can say 0.1 scale, and minimum increment size you can keep it as it is. Okay, if your simulation is not getting solved and undercuts are there, then you can reduce the size of this increment in a minimum value. Okay, let's say you can do the 1 raised to minus 10 raised to minus 9 or 10, you can select. Okay, so your simulation will get solved. Okay, so I have created the static right now. Now in the field output, whatever output you want, you can just click it on. Let's say if you want the energy, you can select thermal. I'm not doing. So whatever you want, you can just select over these parameters. And if you have selected the time points, so you can just select the time points from here if you have created. I haven't created those time points for now because it is not required over here. Okay, now what will be the interaction between the bodies? If this body touch this one, if it contacts with this body, what will happen? It should have some frictional parameters or frictionless parameter, what you want to do. Okay, so you have to define the contact between two bodies. Either it can be manual or it can be auto also. I will apply as auto. Let's say I'm going to interaction for now, and I will create. So in the static condition, it is telling, but I don't want to create in the step 2, which is a static, but I want to create it from initial condition. Okay, so it will be in the context from initial. So I will select that as an initial, and I will create as a general contact, not a surface to surface. If I create the surface to surface, then I have to define every contact, right? That I don't want to waste my time. So in the contact properties, I will select as all with self. Okay, And if there is any complex surface or contact, you can just click the surface to surface contact or node to node. Oh, you can select. Okay, so for now I will select the contact. Okay, write down contact and what type of contact this is. So not a thermal, not a electrical, it is mechanical contact. In the mechanical, I have the tangential behavior, which is related to friction formulation. I will select as a penalty, and I will keep it as a friction coefficient around a 0.27. Okay, if you have a temperature data or a contact pressure data, so you can apply over here. It will give more accurate results. So in the global property assignment, you can select the contact which you have created. It will come in the interaction properties. If you want more interaction properties between separate bodies, so you can just select and create any type of contact, and you can apply for the surface to surface. Okay. Now I will come to the whatever reference point I have created, it will not get connected automatically. Okay, so you have to connect this reference point to your bodies accordingly, right? Let's say I want to apply this RP1 to restrict this body, and this RP3 to this body, and this RP2 to this body. So this will be my rigid parameters. Okay, now I will go to the constraint. Okay, if you select the constraint, there are a lot of options are there. For now, I have taught in the previous videos about MPC and coupling and tie. So I will select the rigid body because I don't want to deform my this rollers. Okay, so I will select as a body which body you have to constrain, and yeah, this will be my rigid body, and whatever reference point, which reference point you want to connect with this rigid body. So if I select RP2, then it will be directly connected to this, but just for a better understanding, I will select as a RP1. Okay, as I told you, wherever you create your reference point, there is no issue, you can create anywhere, any node. Okay, so as same, I will select my body 2, which is directly connected to the RP2. Okay, same I have to do. Okay, yeah, so done. Now as you can see, my rigid bodies are ready. Now it's time to apply the boundary condition, the climax. Okay, so if you give the right boundary condition, then simulation will be correct. Okay, now I want to displace this bar and displace this body, and this need to be fixed, and this should be constrained in a y direction, as you can see, because I don't want to deform as something like it will bend on the z or x axis. So what I will do, I will just go to the boundary condition. You can go to the manager as well, and you can click on manager, and you can create the boundary conditions. Okay, so in the initial, I will make these two bodies fixed. You can just click the shift and select the body, select the RP. Okay, and I will select the U1 is your x axis, UR2 and UR3 will be your rotational axis about y and z. So as a reference, 1 is your x axis, 2 is your y axis, and z is your 3 is your z axis, and whatever UR is there, that means the rotational axis they are talking about. For now, I will select the encaster, which is locked in every direction. Okay, as you can see, in the static case, it has been propagated, so it will be constant throughout the simulation. Now I want to displace this, but I want to check how much displacement I want to do. Okay, it should not too much high, because there will be very large displacement which can lead to the failure of the simulation. Okay, so let's say if I want to do 4 mm. Okay, 4 mm will be better. So I will click the displacement, and I will go to the static, because whatever displacement or force you want to give, you can just give in the next step. Okay, in the initial condition there will be all fixed geometries and constraint will be there, but in the second step you have to apply the force, your displacement, your rotational condition, whatever. Okay, or velocity. So I will clear the displacement of this RP, which will be downside. First I will click the all in the 0. Okay, so it will be fixed in all direction. Now I have to select, so let's say my product is in y direction, so I have to give the minus y. So which will be my minus y? This will be my minus y, u2. Okay, so I have to select the value in minus condition. So let's say I'm going to give a 3.5, and you can apply the amplitude if you need. I will discuss that later also. Okay, so as you can see, my arrow has been created. Now you want to constrain this bar, okay, in the y direction. So what I will do, I will just go to the boundary condition, and go to the initial step and go to the displacement, and I will select this surface and this surface. Okay, I will select, and I will lock every axis except the y direction. Okay, now if I want to see in the manager boundary 3, as you can see, u2 is free. Okay, every axis is locked 0. Okay, 0 displacement in all sides. So in y direction only it will move. So yep, you are done with the boundary condition. Now the main part is meshing. Okay, I will not focus much on the meshing because it will be very easier for this, because it is not very complicated. Now if I want to generate the mesh, it will create an error, something like that. Okay, so read there, dependent part instances cannot be edited or assigned mesh attributes. Make independent. Okay, I have created the dependent. So what you should do, I will go to the part, and here you can see you can mesh them separately. Now I will apply the seed as a 2. So as you can see, I can apply 1. Okay, 1 will be better, I think, because it should be solved very fast. 2. Okay, nice. 2, sorry, 1. I don't want to do bottom up meshing right now. Okay, 1. Now I want to tell you something about this meshing. So whatever simulation you are doing, accordingly you have to select the mesh parameters. If you go to the part, and if you select this one, select regions to be assigned element types. You have to select the element type. Sometimes what happen, you are giving the right boundary condition, right steps, every contact is right, constraint is right, but meshing is also right. But when you are solving the simulation, you will face many errors, right? That a mesh is not correct, mesh is failed. So the only reason that can happen, that if you do a thermal simulation and you are applying the normal like 3D stress elements, so it will not get solved. So what you have to do, you can just select the region to assign the element types. You can select the parts, and whatever simulations you want to do, if you are doing the explicit, this need to be selected as a explicit. Okay, your geometric order should be quadratic if you have a complex geometry, and here the formulation you can select whether you are doing, if you are doing the explicit simulation, which is like cutting, VM, friction stir, or material removal process I am talking about. So you can just click the element deletion, max degradation, right? So these are some parameters you need to focus. So there are many type of elements you can just select. So for now I am on to the 3D stress only because I don't want to go into the deep okay about this one. So you can select your elements accordingly. Now if you want hourglass effect, stiffness and all, you can just go through that. You can just turn on second order accuracy if you want. So these are the things you can explore by yourself. Otherwise I will cover in the future videos because it's very interesting topic, you know. Okay, back to the topic. Now I have selected the job. I will create a job and I have total 12 number of processors, so I will select as a 12, and I have also GPU, so you can just select that also. But for now my directory is what in D direction, but you should locate your directory where you want to save the results. Okay, so in the trash, let's say I'm going to apply in a beam. So let's say I will select as a beam. Okay, now you can just run the simulation. If you want to check your if your parameters is correct or not, so you can go to the data check, which will be a short type of initialization in the ANSYS, which is the same as the data check. Okay, without data check also you can submit the result if you have confidence. So I'm submitting that. Now you can go to the monitor and it is running. Now wait till the results come out. Okay. So now as I have completed the simulation, now I have opened the results, which is a ODB file, output database file. I have decreased the mesh size and increment size and removed this boundary condition on the beam because it was taking a lot of time and increments. So that's why I removed those, and now I can see the simulation how it is bending, right? So these are my rigid bodies, is a fixed condition. Now if I hide this, let's say wait, so you can just go to this one, and whatever you want to hide you can just remove them. And if you want to do animation, so as you can see, yeah, so here your stress is coming higher and this will be your value. And if you want to check the displacement, you can just go to the displacement. It will show you displacement. Yeah, as you can see, if you want to change the scale, let's say I want to change the scale, let me show you a 2 times larger displacement. So you can see that also 10. Okay, so as you can see, this is how you can do a simulation. But this kind of simulation having a very large displacement, that's why it is very hard to solve it in a static simulation. So you can use the dynamic explicit simulations for that, because for the larger displacement that will be good, or dynamic simulation will be also good. And if you apply with the amplitude, so it will be very smoother. And yes, so accordingly you can give, these are some symbols on a deform shape. You can just do a section and see where your stress is coming higher. So on post processing we will have another video, like what are these options. So we will have a video, and how, if you want any graphs, so we will create those also in our future. So yeah, for this video, yeah, that's all. And if you have any query about this or any questions, so you can just ping me down on Instagram, or you can just comment down your question. So yeah, thank you for supporting, and keep learning, keep sharing. Yeah.